Hello, in today's lesson we're going to talk about area of regular polygons, but before we get into that I have a little do now here based on the last lesson for you to try. So just pause the video right now, try the problem out, and then when you're done, unpause and I'll go over it. Alright, so hopefully you already tried the problem. So let's look at this. To start us off, let's look at the shapes we have. We have a trapezoid with a circle cut out of it, and then a triangle cut out of the circle. We want the shaded region. So basically we want everything besides the circle. So as you can see, basically what we're going to want to do here is we're going to want to find the area of the trapezoid first, subtract out the area of the circle, but then add in the area of the triangle that's inside the circle. Luckily, they told us AB is the diameter, and that's actually super useful, especially if you look at this triangle. You can notice that we have a 30, 60, 90 triangle here. How do I know that this angle is 90, you might ask? Is because I see that it's an inscribed angle of a diameter, right? AB is the diameter. So based on the last unit on circles, we know that that's a 90-degree angle. So we have a 30, 60, 90 triangle. So if this is 30 over here, and I know this is 90, that makes this one 60. Across from 60 is 6 root 3. Going back to our trig unit, we know if across from 60 is 6 root 3, across from 30 is just going to be 6. And if across from 30 is 6, across from 90 is going to be 12. So 12 is the actual diameter of our circle. Alright, so now that we know our diameter, it's going to be really easy to plug into our circle formula to solve for the area of the circle. That's just going to be pi r squared. So pi times the radius, which is half the diameter, 6 squared. That's going to be 36 pi. So now we have one piece of our equation. So now we also have to figure out the trapezoid and the triangle itself. Well, actually, the triangle is not going to be too bad either because we already know the base is 6 root 3 and the height is 6. So 1/2 base times height, that's going to be 1/2 of 6 times 6 root 3. So basically just 3 times 6 root 3, which is 18 root 3, right? So now we just need to figure out the trapezoid. So the trapezoid's a little tricky because trapezoid we know is 1/2 both of the bases added together times the height. We just don't know the height, and we also don't know the size of this base. Luckily, we see that the circle that we have is perfectly inside the trapezoid such that the top and the bottom of the circle hit the bases of the trapezoid. So if we only knew the distance between the top and the bottom, we would know the height of the trapezoid. Well, we actually already figured that out. We know that the diameter is 12. So if the diameter of the circle is 12 going from A to B, the diameter of the circle is going to be 12 going from the top to the bottom as well. So the height is actually 12. That doesn't really tell me what the base is, though. However, if I take that height of 12 and I strategically place it in this trapezoid, I can create altitudes with that same value, that same height of 12. And now I have right triangles where one of the sides is 12 and the hypotenuse is 13, well, that's a Pythagorean triple. So that means my third side is 5 in both of these scenarios. So if both of those are 5, and this outlines my rectangle, that means if this side's 15, this side's also 15. So 15 plus 5 plus 5, that means this base is actually 25. So now I can plug into my trapezoid formula 1/2. The bases added together, so 25 plus 15, that's going to be 40. So 1/2 of 40 times the height, which I know is 12. So 1/2 of 40 times 12, that's going to be 20 times 12, so that's 240. I'm going to be subtracting out the circle, 36 pi, and adding the triangle, which is 18 root 3. Now, because we have a whole number, a number times pi, and a number with a radical, none of those can actually be combined if we want to keep it in simplest form. So really, this would be the simplest form. However, if you want to know what approximately this answer is, I plugged it into a calculator already. It's about 158 1, 4. All right, on to today's lesson. Today's lesson, like I mentioned before, is about finding the area of regular polygons. We already know how to find the area of basically every other two-dimensional shape from the last lesson. The only one left is regular polygons because it is a little different than the rest of them. Basically, the most important thing to finding the area of a regular polygon is going to be knowing what the apothem is. Basically, the apothem is really just a line from the center of the regular polygon to any side of the regular polygon. And because it's a direct distance, it's going to be perpendicular to that side, creating that right angle. And it's also going to split the side into two equal halves. Okay, so now if we want to derive the formula for any regular polygon, what we can do is actually take any of our regular polygons and we can split them so that every side creates an isosceles triangle. Once we have that isosceles triangle, we could then draw the apothem in. And if we draw the apothem in, that's actually the height of the triangle, and the side of the polygon is our base. And we know how to find the area of a triangle already. That's 1/2 base times height. So since, for example, here we have a pentagon, since a pentagon has 5 sides, if I find the area of one of the triangles and I just multiply it by 5, that's going to be the total area of the pentagon. So really our area formula is just going to be area equals 5 times the area of one of the triangles inside the pentagon. Likewise, if we then go down to the hexagon, I could take the hexagon, I can draw in one isosceles triangle from the center, and if I draw in that apothem, again, I have a base and a height of a triangle, but now the difference is I don't have 5 sides anymore, I now have 6 sides, which means I'm going to be able to create 6 of these triangles. So my area formula is now going to be 6 times 1/2 the base times the height. Okay, so now go ahead and find the areas of a heptagon, octagon, and nonagon. I mean, based on what we already talked about, this should be pretty easy, and then we'll come up with a formula for any sided polygon. Okay, so there are the formulas that you should have determined for heptagon, octagon, and nonagon. Now, if we continue the table indefinitely and we get to n number of terms, where n is really just any arbitrary value for the number of sides of our polygon. Basically, as you can see from the rest of the table, when it was 5 sides, I had 5 times 1/2 base times height. 6 sides, 6 times 1/2 base of height. 7 sides had 7 times 1/2 base times height. So, if I have n sides, the area is going to be n times 1/2 base times height. So really you're just finding the area of one of the triangles and multiplying it by the amount of sides there are. However, there's actually an easier way to write out this formula. If you think about it, what happens when you multiply n times b? If b is the measure of one side of the polygon and n is the amount of sides of that polygon, what can we switch b times n for in our formula? Well, what winds up happening is if we take the size of one side and multiply it by the number of sides, that's really just the perimeter of the regular polygon. So basically, since we just determined that if you multiply the size of any side of a regular polygon by the number of sides, you get the perimeter, we can now make a shorter equation. So that shorter equation is going to be 1/2 of the height of one of the triangles times the perimeter of the regular polygon. And since we know the height of one of the triangles is actually just the apothem in this situation, we can actually write our equation as area equals 1/2 apothem times perimeter. And that's going to be the equation for the area of any regular polygon, no matter how many sides there are. Okay, so let's look at these two practice problems. Now, these are what I would consider like really nice area of regular polygon practice problems because Not only do they give me the apothem, but they also give me at least one of the side lengths, and they are showing me how many sides there are. So really I have all the information I need here. So I see that the apothem here is 14, and I have a side length of 13. And if I look at the picture, I see that there's 7 sides to this polygon. To find my perimeter, I'm going to first do 13 times 7. So that's going to give me my perimeter. My perimeter is 91. So then to find the area, I'm going to do 1/2 of that perimeter times the apothem, which I know is 14. So half of 14 is 7. So really, I'm just doing 7 times 91 here. And I get an area of 637. And they didn't give me units, so just units squared. All right. So take a second, try out number 2, and pause the video, and when you come back, I'll go over number 2. Okay, so for number 2, I see one of my side lengths is 12, and I see that this is a 9-sided figure. So first thing, I'm going to find the perimeter. I'm going to do 12 times 9. 12 times 9 gives me 108, so that's my perimeter. And then to find the area, I'm going to do 1/2 of the apothem times the perimeter. The apothem is 16. So I'm going to do half of 16 is 8, so 108 times 8 is going to give me an area of 864 units squared. Okay, so now moving on to a more difficult problem. So if we look at this question, we know that it's a 6-sided polygon, and we know the apothem, but what they don't tell me is at any of the side lengths. So if I don't know any of the side lengths, how am I supposed to find the perimeter? So in a situation like this, basically what we want to do is we want to create a right triangle, which luckily we know that the apothem always creates a right angle. So what I can do is I can actually just draw one line from the center to one of the edges of the regular polygon, and that creates a right triangle for me. Now, just knowing I have a right triangle on one side isn't really going to do anything for me. But if I could figure out what this angle is, then I can use SOHCAHTOA, or in some instances, special right triangles, to figure out the side length that I'm looking for, which is this side length right here, right? So to do that, I'm going to think about how many of these right triangles could I make in a hexagon. And basically, the answer is going to be the amount of sides times 2. So, since there's 6 sides, I can make 12 right triangles. And I know that all of the angles of these right triangles should add up to 360 because they create a circle. So, 360 divided by 12, that in this case is going to give me 30 degrees. Now, this puts us in a really advantageous situation, because if I know this angle's 30, this angle's 90, I have a 30, 60, 90 triangle, which is going to be easy to solve for our side that we're looking for. So if I know across from 60, right, this angle, across from 60 is 6, then across from 30 should be 6 divided by root 3, which is really 6 root 3 over 3, which is really just 2 root 3. So if I know this portion of this side is 2 root 3, and I know the apothem cuts the side directly in half, that means the entire side is 4 root 3. And now that I know that, I can use my formula 1/2 apothem times perimeter. So 1/2, my apothem is 6. My perimeter is going to be 4 root 3 times 6 sides. So that's going to be 24 root 3. So half of 6 is 3. 3 times 24 is 72. So I get 72 root 3. And again, we don't have units, so units squared. And that's going to be my area of this regular polygon. Again, they only gave us the apothem in this scenario, and we're still able to figure out the area. Now moving on to what I would consider actually a more difficult problem. In this case, we do not have the apothem. We only have one side. Luckily, we can actually solve this the same way we solved the last problem. Unluckily, however, is that this is a pentagon now, and a pentagon is not going to divide out of 360 as nicely as the hexagon did. So let's approach this the same way we did the last problem. I'm going to draw in the apothem this time, so I'm going to make that right angle from the apothem, and I'm going to draw the line to the edge of my pentagon. And now I look at this, I say, all right, I have one right triangle, there's 5 sides, so that means there's going to be 10 potential right triangles. So we think about that, we say, all right, well, 360 divided by 10 tells me that the angle I'm going to create is a 36-degree angle. So now I have a 36-degree angle. I know that the side length across from it is 8, which again, apothem splits it in half, so really the side length I'm going to be looking at is 4. So I have an angle, right? I have this angle, I have this side, and I want my apothem. So in this scenario, I have an angle, an opposite side, and I want an adjacent side. So looking back to our trig unit, if we think about SOHCAHTOA, I'm going to want to use tangent here to solve for my adjacent side, x. So I'm going to use tangent of 36, right? That's what we determined that angle was, equals the opposite side 4 over the adjacent side x, which is what I'm looking for. So now to solve for x, I do x equals 4 over tangent of 36. I plug that into my calculator and I get about 5.5. So now I know my apothem is 5.5, so now I can go to my area formula, 1/2 apothem times perimeter. Area equals 1/2, my apothem is 5.5, about, again, that's an approximate, times the perimeter, so one side was 8, there's 5 sides, so my entire perimeter is going to be 40. So 1/2 of 40 is about 20. 20 times 5.5 is going to be 110. Again, no units, so I'm just going to write units squared here, and that is my answer. So again, this isn't really much harder than the last question. We're still following the same steps here. The difference between this problem and the last problem is that in the last problem, because there was 6 sides of the polygon, I was able to create a 30-60-90 triangle, which I always find easier to solve for sides in 30-60-90 than obviously in a triangle where one of the angles is 36. 36, I'm going to have to use SOHCAHTOA. I can't use a special right triangle here. Okay, so here's our last question for the day. What I want you to do, again, is pause the video, try this one on your own, and then come back to it. I'll have the answers written out, and I'll explain how to get to the answer. All right, so here's our answer. So there's a few steps here. The first thing is that we're starting with the apothem, and we want to solve for the side length using that apothem. So we make this right triangle here. We have to figure out what this angle is. So we do 360 divided by 16, because again, there's 8 sides. I'm going to be able to make 16 triangles. So if I make the whole circle and divide it into the 16 triangles, I get 22.5 for each of the angles here. Once I know that angle, I can then set up my trig proportion. Tangent of 22.5 equals the opposite x over the adjacent 5. So then I solve for x, I get 2.07. Really, I don't want x, I want the entire side. And again, the apothem splits the side in half, so if I double the number I just found, I find that all the sides are 4.14. So now to find the area, I do 1/2 the apothem, which is 5, times the perimeter, which is going to be 4.14 times 8, because there's 8 sides. So that's 33.12. I plug that in my calculator. I get about 82.8 units squared. Okay, so I hope you found this lesson pretty thorough. If you were confused about something, it's a video, so you can always rewind and watch, pause, slow it down a little bit. So what I want you to do for homework is I posted a couple practice problems just on area of regular Polygon, so I want you to do that for homework. And then tomorrow I'm going to post some review of all the area formulas for you to work on, and you can join me on Google Meet and ask any questions you have on anything from the past 2 lessons. Okay, have a good day, guys.